Final question in this section we're going to take a look at is AS2 from January 2010. We're working without a mark scheme here, so we're not sure just exactly what the examiner's be looking for, but we're going to just explain what the answers to the questions are that we would give. So explain the meaning of the term interference. Now, interference is a wave property. It's the property that occurs when a wave from two coherent sources overlap and produce a pattern. So what is interference? Well, interference is the pattern produced when waves from two sources overlap and superpose. So it's really the superposition pattern there. What signs and conditions must exist for an interference pattern? Okay, well, the waves that overlap must come from coherent sources. That's this whole idea of coherent sources, that's very important. And whatever they're coherent sources means that they're phase linked and have the same frequency. Now, the phase link, generally speaking, that we adopt is keeping them in phase. So you could say they're in phase with the same frequency, because that's mostly what happens when we're doing it. But coherent just means phase linked and the same. So the essential condition is that the two sources must be coherent. So the two sources producing those waves that overlap must be coherent. Now, this is an interesting part of this next question. What other conditions should exist for there to be good contrast between the bright and dark fringes in the pattern? Well, for that to happen, for good contrast, the waves overlapping must have the same or approximately the same, so must have similar or the same amplitudes. Okay, and remember, so if you have a wave like that overlapping with a wave like that, they will cancel out to give you complete cancellation. But if one is like that and the other is like that, then they will still give you a wave like that. So you won't see the contrast between the maximum and minima as much as you will for here. So this gives us complete cancellation, this just gives us partial cancellation. So similar amplitudes gives us complete cancellation, which gives us good contrast. Alright, the screen is now moved closer to the slit so that the distance between the screen and the slits S1 and S2 is half its previous value. State and explain two differences between the interference pattern now observed on the screen and the original pattern. Alright, so what we're going to see now, so the screen's moved closer to the slits so that the distance between S1 and S2 is half its previous. So what we're going to notice now is that the fringe separation is going to be different. And how will it be different? Well, because we've halved the difference, the fringe separation will be smaller. Okay, and the fringe separation y is equal to lambda d over a. So what has happened here is, okay, well, lambda stays the same, the separation stays the same, the separation of the slit stays the same, but d has got smaller, therefore the fringe separation will have got smaller. Right? So in order to explain that, what we're saying is as lambda and a remain constant, as d decreases so will Y, and so the fringes will be closer. Alright. Now we have to think in terms of a second thing that we could observe, a second difference. Well, the next difference there that there would be is that the pattern would be brighter. And why is that? Well, again, the light has less distance to travel to the screen, and so there will be less attenuation occurring. Okay, so there's less attenuation. Attenuation is just whenever you move from, okay, if this is the source at this point here, okay, as you move away from that, then what happens is the intensity of the light drops. So that would be intensity against distance from the source, and so it drops. So that attenuation is going to be less if you're out here, much less intense, up here, much greater intensity, and so the brightness would be better.